Hello everyone. So very good morning to all of you. So my name is Annu and I am a PhD scholar at IIT Hyderabad. So today I am presenting a joint work by C-DAC and IIT Hyderabad, TiHAN IIT Hyderabad for the connected vehicle testbed for real-time deployment of use cases at IIT TiHAN IIT Hyderabad. So moving ahead. So if I talk about the CV2S ecosystem, so generally the CV2S means cellular vehicle to everything. And the V2X comprises of several communication things. So first of all, it is V2V, that is like vehicle to vehicle. And the second one is vehicle to infrastructure. And third is the vehicle to network. And fourth is vehicle to pedestrian. So in this work, we have deployed some of the use cases and also we have the videos for the use cases and we have checked the KPIs like whether it is performing well or not. So it actually supposed to road safety. So as you can see from the architecture, we are having in the TiHAN IIT Hyderabad this particular architecture in the background. We have the CV2X OVU that is onboard vehicle and CV2S RSU that is roadside unit. So with the using that supports 5G V2S communication and through that we are deploying the use cases. Use cases means here that particularly, we have to develop the alert and whether that is performing well or not, we have checked that. So moving ahead, so if we talk about the V2S system, that is the hardware that I'm talking about. It consists of the V2S system that has several subsystems. The first subsystem is a security subsystem that is based on IEEE 802 point something background is there. And the second is the processing subsystem that is having the stack, particular stack. And the stack that we have developed, hello, yeah, the stack we have developed from on scratch by the C-DAC team and in collaboration with TiHAN IIT Hyderabad. And there is a security stack separately for that, I will come on that. And the third subsystem is the wireless subsystem that is a modem with RF devices. And there we will have the antennas that is supporting the MIMO system. So we are having 2+1 MIMO system and that will steer the beam in a particular direction. And similarly, as you can see from the processing subsystem, we are taking the vehicle data. So this data we are taking at a frequency of 10 hertz, and using that data, we are developing the alerts. So positioning system is also there, that is a GPS, and the augmentations are there, and some of the IU sensors are on board kept on the OVU. So so V2S components in the vehicle architecture, the core concept is again, it is integrated into vehicle architecture to enable the communication with all the road users. The main elements are wireless connectivity, sensor integration. Here, the sensor integration only helps us to get the data and deploy some of the use cases. And the third is the vehicle compatibility. So if I talk about simply the V2S, C-V2S architecture in terms of the OV and RS, what is the frequency band that it supports? So it is supporting the ITS band, that is a 10 megahertz, because it is a silent communication we are talking about. Even if we talk about vehicle to everything and vehicle to vehicle, we are just taking the silent band of 10 megahertz and at a center frequency of 5.9 gigahertz. So this is the architecture. If we talk about the perspective of 3GPP, so what is the core and what is the RAN part? So if you can see the core part is same as per the 5G, like 5G communication. But similarly, if you can see this RAN, so there the stack is different. So here in that stack, we are developing the video stack from the, if we talk about the stack comprises of different IEEE standards. So most of the standards that we have taken is IEEE 802 and the standard for the 5G signaling is from the 3GPP release 16. And here we have same AMF, SMF, access mobility functions, session mobility functions, the network functions as per the 5G code. So if we talk about CV2 standard that is there as per the existing literature is dedicated short range communication and the same Wi-Fi stack is deployed over the CV2 stack because we are having the DSRC boards also in the TiHAN IIT Hyderabad and CV2 stack defined with the release 14, 15, right now we are supporting 15 And the V2N, it uses a cellular network that is a 5G core, backend is supporting the 5G core, and through cycling it's a PC5. So PC5, if we talk about PC5 UI interface, there is a direct vehicle to vehicle communication that is through the PC5, and it operates in latency sensitive areas. Whereas if we talk about more latency tolerant use cases, then we use a V2N. So there the cloud connectivity will take place. So these are the standards of CVTOS release 16, and in CVTOS release system, we are having the resource allocation, that is a sensing-based semi-persistent scheduling. In that, the vehicle will operate on the specific band of based on the sensing result, and it will select the resources based on the sensing result, and it will reserve the resource for some particular amount of time. That time is determined by TTI, and these are all the standards. And this is implemented in our devices also. So this is the protocol stack that I was talking about. So this is a V2X communication protocol reference model. So this is based on the ISO 21217. So here you can see we are having different layers, such as application layer. And here the application layer, we are changing the configurations for deploying the use cases. That is for the road safety, traffic efficiency, infotainment, automatic driving, and industrial applications. So in the network layer, we have IPv6, and we can configure with respect to IPv4 also, but IPv6 performs well, and TCP protocol is used. And here we can see NRV2X, we are having the similar stack, physical MAC, RLC, PDCP, RRC, and SDAP layer. So as per the CV2S indigenous development in TiHAN IIT Hyderabad, in collaboration with C-DAC, we have developed the indigenous hardware and software stack for the CV2S that includes OBU and RSU that suppose IEEE 1609.x, that X can be different versions compatible, and the 5G V2S as per 3GPP release 15. And these modules are designed to operate within the existing CVTOS band, that is again 3GPP release 15 band. So these are the hardware, and these are the configurations accordingly. We have RSU that is capturing the poles that is acting as a base station also, and we have the OBU. And then the only difference between OBU and RSU is we are having the Bluetooth compatibility with the OBU, through which we can get the app alerts, whereas in RSU we don't have. Otherwise, the band is same, but the difference again is it supports upgradable to 5G also. The SIM capability is 4G, and upgradable to 5G, it can be upgradable to 5G, but the cycling is 5G. So that cycling only we are using. So this is a CV2S communication stack that is according to again this 1609 standard. And we are having the security services. This is according to IEEE 1609.2, and different management and services also there. So this, if you all talk about which are the messages that we are taking. So this is the SAEJ2735 message format it supports. So globally, this standard is only followed. So we are also using that message. So application flow. Now, after developing the application, what is a flow? So we are having the application uses a 0NQ interfaces to communicate with the CVTO stack. The stack is developed in the hardware, and we are using on top of 0NQ services on the application layer to communicate with the CVTO stack. So the 0MQ, if we talk about, is in a high performance messaging library for distributed application. So because a multi-threading is also used in order to facilitate different applications at one time. So it supports messaging patterns like publish, subscribe. So we can use different protocols like MQTT and all, but we have compared that this is performing better than that. So it uses over the multiple transport, as is in our case we are using TCP, and all the application uses 0MQ interface for the data and control message transmission. So if we talk about our testbeds features, so we are having active safety, passive safety, and videos communication. So passive safety we don't have. But if we talk about MCT USA, that is the University of Michigan, that is having the similar facility, and KCT having a similar facility, but the other one, which is a JARI Japan, are having the same all facilities. So these are the use cases that is there. This is the V2I use cases. I don't know how to run this video. I clicked it, it's not running. Ashik, can you please once? It's running. So as we can see, this is the alert generated for V2I. So what it is actually doing is the RSU kept in the pole. It's giving the live video stream that we are capturing in the server. And the server, the deep learning model is running that is detecting the pedestrian. And that is giving the alert through the OBU. So the OBU is there in the vehicle. So vehicles are moving around the campus or the TiHAN IIT Hyderabad. So whenever there's a stream, that the monitoring RSU is having the stream, and whenever the pedestrian is detected, that alert is given, passes to the vehicles. So wherever the vehicles are there, vehicle will get to know that pedestrian is there. So one of this V2I pedestrian detection is there that we are utilizing. Where the RSU is utilized. So V2V collision warning is also there. So if you can see, there are two vehicles moving, and whenever the collision is there, the vehicle will be getting alerted. This collision is there, and the alert message can be slow down your speed, or you can change your direction like that. So this is through the V2V communication. So this is for the emergency brake warning. So vehicle equipment V2V communication exchange the basic safety message at every 10 hertz, and they will get to know if emergency brake is applied, because whenever the front vehicle applied the emergency brake, the other vehicle will not get to know about that. So through V2X communication, we are giving that alert. So this vehicle got the alert. We can see that. And this is V2I for the pothole detection. Again, we are utilizing this the camera stream to the RSU to the IP message, and then the RSU will give the alert to all the OBUs. And this deep learning model will be running in the server backend. This is for the blind spot detection. So the RSU calculates the distance and the speed of approaching vehicle. It triggers an alert if the blind spot of the curve, the road is detected based on the set threshold. So based on the Road Authority of India, we can just keep the thresholds and we can give the alerts. So these are the use cases that are deployed, and there are several few use cases that we haven't covered. So I think with this word, I would like to take your lead. Thank you so much. So these are the references.